For almost 60 years, every serious astronomer on Earth believed there was a planet hiding next to the Sun. It had a name, it was printed in textbooks, and men swore they had watched it cross the face of the Sun with their own eyes. It does not exist. It never did. And the reason they went chasing a ghost for 60 years wasn't stupidity or a hoax or bad telescopes. It was this planet, Mercury, the little grey rock we treat as the boring one. The planet everyone skips on the way to somewhere better was doing something that, under the laws of physics as everyone understood them, could not happen. The error was tiny, so small you'd never notice it in a lifetime of looking, but enough to convince the smartest astronomers alive that an invisible planet simply had to be out there. Enough, eventually, to bring down 200 years of physics. So they had two choices: invent a planet to explain it, or admit that everything they knew about gravity was wrong. They chose wrong. For 60 years, they chose wrong. This is the story of the planet that broke the rules, and it didn't stop with gravity. Start in the middle of the 1800s, at the peak of Isaac Newton's reign, when Newton's gravity didn't just explain the sky, it predicted it so precisely you could find planets with math alone. And one man had just done exactly that. A Frenchman named Urbain Le Verrier noticed the orbit of Uranus was being tugged by something unseen. He did the math, mailed the coordinates to an observatory, and that same night they found Neptune, almost exactly where his numbers said. A planet discovered with nothing but a pencil, and it made him the most trusted mind in astronomy. So when Le Verrier turned to Mercury and said something is wrong here, everyone believed him, because Mercury was moving in a way it was not supposed to move. An orbit is meant to be a fixed loop, the same path traced forever, but Mercury's wouldn't hold still. The whole thing was slowly creeping around the Sun. Most of that drift, Newton's math explained easily, from the pull of the other planets. Most of it. There was a scrap left over, a tiny piece of motion no known force could account for. And no matter how many times Le Verrier reworked a century of observations, it would not go away. It was almost nothing, and almost nothing was a catastrophe, because Newton's gravity had never once been wrong. And here was a planet quietly disobeying it. So Le Verrier did the only thing that made sense, the thing that had worked before. There must be another planet, something small, hidden in the Sun's glare, close in, tugging on Mercury. He named it after the Roman god of fire, Vulcan, and the hunt began, a hunt that would swallow the next 60 years. It started with a country doctor, an amateur named Lescarbot, who announced he'd seen it. A small dark dot sliding across the Sun. Le Verrier questioned him and walked away convinced. The greatest astronomer alive staked his name on it, and Vulcan went into the textbooks as the newest planet in the solar system. For the next 60 years, astronomers dragged their instruments to the ends of the Earth to catch solar eclipses, those 2 dark minutes when the Sun's glare dies, and spent them hunting a planet that had to be there. Except it wasn't there. Every sighting fell apart. Every eclipse came up empty. And decade after decade, the ghost refused to appear. And slowly, a far more frightening possibility crept in. What if there was no hidden planet? What if the reason Mercury broke the rules was that the rules were broken? Nobody wanted to say it out loud. It would take an unknown clerk in a patent office to finally say it. His name was Albert Einstein. And in 1915, he wasn't trying to find Vulcan. He was trying to rebuild gravity from scratch. Einstein's idea was strange enough that most people couldn't picture it. Forget gravity as a force pulling across empty space. Picture space itself as a fabric, with heavy things sinking into it, bending it, so that what we feel as gravity is just objects rolling along those curves. And the closer you get to something massive, like the Sun, the more brutally that fabric bends. No planet sits closer to the Sun than Mercury, which means no planet rides through more badly warped space. Mercury was the perfect test. If Einstein was right, his new gravity should predict Mercury's orbit. The whole thing, including the scrap Newton couldn't. So he ran the calculation, and out came a number: 43 arcseconds per century. That number is the reason you know Einstein's name, because 43 was the exact size of the leftover scrap, the same stubborn piece that had haunted astronomers for over half a century. Not close, not roughly, exact. There was no Vulcan, and there never had been. Mercury's orbit drifted because gravity itself did not work the way humanity had believed for 200 years, because space and time can bend, and near the sun they do. Sit with how strange that is. This planet we call boring had been holding up a sign the entire time, a sign that said the universe is deeper than you think, and we spent 60 years inventing an imaginary world rather than read it. Mercury didn't get interesting when Einstein showed up. It had been screaming the truth since before we were listening. That's one broken rule: gravity itself. And then we finally sent a machine to Mercury and looked closely, and found out the outside was the least of it. When scientists modeled how Mercury was built, they expected rock. Every terrestrial planet follows the same basic blueprint: a modest metal core buried under a thick stony mantle. Earth is built that way, so is Venus, so is Mars. A small core, a lot of rock. They expected Mercury to be the same. It isn't. Mercury is almost all metal, its iron core filling about 85% of the entire planet. The rock we picture, the mantle, the crust, is a thin shell smeared over a giant metal ball. Mercury isn't a rocky world with a core. It's a core wearing a little rock like a coat, and nothing else in the solar system is built like this. And it shouldn't be possible. A planet forming here should keep a normal thick coat of rock, but Mercury's is mostly gone. Something tore it away. The leading suspect is violence, that the Mercury we see is a survivor, that a young, bigger Mercury was hit by something enormous, a collision so savage it blasted the planet's entire rocky outer layer off into space and left the naked iron heart behind. We may be looking at the wreckage of a world that used to be twice the planet it is now. Maybe, because here's the honest part, we don't actually know. The impact story is our best guess, and it doesn't fully add up, and it's one of the real reasons we keep going back. A planet should not be mostly metal. This one is, and that oversized metal heart should be doing something. Instead, it's doing the one thing it can't. A giant iron core should make a giant magnetic field. Mercury barely has one, and the little it has makes no sense at all. To make a magnetic field, a planet needs a molten, churning core, a spinning dynamo of liquid metal. Earth has one, and it's why we have a magnetic shield. Mars had one, and it died. When Mars's core froze, its field switched off, and the Sun spent the next billion years stripping the planet bare. Mercury is small, and small worlds cool fast, so Mercury should be frozen solid inside, dead like Mars. It isn't. Somehow, after 4.5 billion years, part of that enormous core is still liquid, still moving, still generating a faint, stubborn field, and we're not fully sure how. But that's not the strange part. The strange part is where the field sits. Picture a bar magnet inside a planet, right in the center. That's Earth. Now picture that magnet shoved halfway up toward the North Pole, badly off-center, lopsided. That's Mercury. Its magnetic field is displaced, pushed north, tilted out of the middle of the planet. Ask why, and for a moment it sounds like scientists have the answer. Maybe the core churns unevenly, stronger in the north than in the south. Except every model that explains the offset breaks something else. So the honest, uncomfortable answer is they don't know. In their own papers, the word they use is unexplained. A crooked field on a planet that shouldn't have a field, orbiting inside the world that already broke gravity. And Mercury still isn't finished, because the next rule it breaks is the one you'd bet your life against. Mercury is hot enough to melt lead. The side facing the Sun hits around 430 degrees Celsius. No hotter surface exists that you could ever stand on in the solar system. A planet baked in a furnace, day after day, for billions of years. And it is hiding billions of tons of ice. Not underground, not buried where it's shielded. Ice, frozen water, sitting right on the surface, on the planet closest to the Sun. How? Here's the trick. Mercury stands almost perfectly upright as it spins, with no tilt to speak of, and because of that, at its poles, there are craters so deep and so precisely angled that the Sun has never once reached the bottom of them. Not in 4.5 billion years, not for a single second. Down there, in permanent darkness, the temperature never climbs. It sits hundreds of degrees below freezing. Pockets of eternal winter on the planet nearest the fire. And in that cold, water has survived. Not a trace. An estimated quadrillion kilograms of ice, hoarded in the dark floors of polar craters, first spotted by radar from Earth and then confirmed from orbit. Frozen water may be dropped off by comets over billions of years, locked in the only place on a burning planet the Sun can never touch. The hottest world you can stand on, keeping ice. Mercury is, at this point, just showing off, and it saves one of its best tricks for the sky itself. Stand on Mercury and wait for a single day, and you'll be waiting 2 years. Not a figure of speech. On Mercury, one sunrise to the next takes 2 full Mercury years, so the day is literally longer than the year. But that's not the weird part. Watch that long day closely, and the Sun does something no other sky in the solar system does. It rises, it climbs, and then, near midday, it stops, hangs there, and starts moving backwards, sliding back across the sky, retracing its own path, before pausing again and finally turning towards sunset. The Sun going into reverse, not clouds, not an illusion, because Mercury has no real atmosphere to trick you. Just the raw mechanics of a planet whose lopsided orbit, at its fastest, briefly outruns its own slow spin. A day longer than a year under a sun that changes its mind. And that same vicious closeness to the Sun, the thing that bends its space and reverses its sky, is about to give Mercury the most beautiful, impossible thing of all. Something we didn't even find until this century. Mercury has a tail, not a metaphor. A real one, a glowing streamer trailing behind the planet, millions of kilometers long, exactly like a comet. Stop on that for a second, because it should not be possible. Tails belong to comets. A comet is a dirty snowball that swings near the Sun. Its ice boils away, and it trails that famous glowing tail. That's the deal. Planets are solid, heavy, whole. Planets do not stream themselves across space. Mercury does. And we only found out by accident. In 2001, astronomers at a Texas observatory were looking at Mercury through a special filter and saw a faint glow reaching off the planet into the black. Their first thought was the obvious one. The equipment's broken, a smudge, a glitch. It wasn't broken. The glow was real. We thought only comets could do this. We were wrong. The planet closest to the Sun was slowly evaporating. The Sun is so brutal here that it physically knocks atoms, sodium mostly, straight off Mercury's surface, and the pressure of sunlight itself sweeps them out behind the planet in a vast, glowing trail. And vast is not an exaggeration. Mercury's tail stretches around 2.5 million kilometers into space, roughly 700 times the width of the entire planet. A tiny rock dragging a streamer longer than the distance from here to the Moon, several times over. You can't see it with your eyes because it only glows in one exact shade of light, but it's always there, which means the closest planet to the Sun is very slowly losing itself to space, one atom at a time, trailing the evidence behind it like smoke. A planet quietly burning away, wearing a comet's tail. The drifting orbit, the stripped heart, the crooked field, the buried ice, the backward Sun, the tail. Every one of them a rule broken, and every one of them a question we still can't fully answer, which is exactly why, after all this time, we're finally going back. We have properly visited Mercury exactly once. One spacecraft studied it until it ran out of fuel and crashed into the very surface it came to understand. Almost everything you just heard, the metal heart, the crooked field, the hidden ice, came from that single mission, and it left more questions than it answered. That changes now, because right now a spacecraft called Bepi Colombo is closing in. A joint European and Japanese mission, 7 years and billions of kilometers into a slow, looping chase just to bleed off enough speed to stop. And in November of 2026, months from now, it's set to slip into orbit around Mercury. It was built for exactly these mysteries, to weigh that impossible core, to map that lopsided field, to read the ice in the dark and the tail in the light. And that's the thing about the planet we call boring. It's almost close enough to touch, bright enough to see with your own eyes, and we've watched it since before we could write. The entire time, it has been quietly breaking our rules, bending gravity, hiding a heart too big, wearing frost in a furnace and a comet's tail on a rock, waiting for us to look closer. For 150 years, it's been the quiet one at the edge of the sun's glare, holding more secrets than worlds 10 times its size. In a few months, we finally start getting answers. The ghost planet was never real, but everything it was hiding still is. Thanks for watching. I'll see you in the next one.